photoelectron. This will have maximum kinetic energy, and there's an alpha particle which is at rest. So what is Kmax? Kmax, he has given some H here. H equal to 4.14. So first we'll calculate Kmax from photoelectric effect. There is some very difficult to imagine, better draw diagram. That's what I feel. Even here also you can bring the diagram. And this is that helium. Sorry, alpha particle. Afterwards it will become helium. No? So alpha particle. Kmax should be equal to Sc by lambda minus work function. 6.624 into 10 to power of minus 34, 3 into 10 to power of 8, lambda 400 into 10 to power of minus 9. Solving this, I'll end up with electron volt. This will come in joule. Then I'll divide charge of electron, I'll get the electron volt. Or H value can directly substitute because electron is telling no. If you substitute this H, then no need of that dividing that one. It's left to you. So again, I have to adjust thing called that one. Just I calculated joule, then divide by charge of electron, then I'll get the kinetic energy 3.1 electron volt. You'll get same answer, nothing. Okay, I got this particular thing. Now this particular kinetic energy of photoelectron, let me call K. Now, O will capture alpha particle. Alpha particle, when it captures, it will become helium plus, it will become atom. It will become atom. And the meanwhile, it will give out one photon. Lambda dash, you call it. Fine. So this much is there. Helium again, where a maximum energy electron combines with an alpha particle to form helium ion, emitting a single photon in this process. Helium ions thus formed are in their fourth excited state. They're not in ground state. Fourth excited state. Fourth excited state means n equal to 5. Helium atom is formed where helium plus in n equal to 5. If you know the energy of helium atom in the n equal to 5, no need to calculate straight away. You can make this problem very easier. What is energy equation you are going to write it? Overall energy should be conserved. And initially far away, no alpha particle, no interaction potential. So therefore the energy equation will be kinetic energy of incident photon, EK, or incident photoelectron. This should be equal to, and what is the kinetic energy of alpha particle? Alpha particle at rest, nothing is there. Then it will form helium atom where E5, I'll write it. Helium atom, helium, so helium plus energy of the photon, Sc by lambda dash. Okay, do we know EK? Yes, we know this one. So we'll get the H. From that, what pen we'll get this lambda dash. Find the energies of photons lying in the 2 that are likely to be emitted during and after the combination. During means when helium atom is being formed, a photon, this will be emitted. And it is n equal to fifth state, again to come to the ground state. So what it will do? It will give out photons, no? What are the photons? Lambda phi 1, lambda, phi 2. I think so many are there. I think I have to draw plenty here. I have to write plenty. This lambda is what? Lambda, again, symbol will be there. Not one lambda, plenty of photons, I'll write. N equal to phi, how much will be? Phi into phi minus 1. Anybody? How many lines? 10 lines. 10 photons. 10 photons of different wavelength. Please try to imagine. So this is what happens here. This is during emitted photon during, I'll write clearly things. During helium plus is formed. What about this? 10 photons of different wavelength emitted after helium plus after and during. I think, is it okay? No is so something. Let's calculate. We don't know lambda dash. No, is it lies between 2 electron volt and 4? We don't know. We should calculate that. Now, what is the energy of helium in the nth orbit? Z square R H C. I think you can directly, no need to. If you forgot, this is 3.1 electron volt. R 13.6.
1.2, sir.
Which one?
EK, kinetic.
Oh, finally. This is the HC by lambda, no? Sorry. This one will be. Yeah. This will be how much?
1.2.
And this is equal to 3.1 electron volt. Okay, that one. I think SC by lambda is what I wrote. This should be equal to how much? 3.1 electron volt. K max or EK is equal to SC by lambda minus work function. This should be equal to how much? 1.2. Okay, no, get into. So this will be 1.2. So some corrections I made. This one, 13.6 electron volt. Now what you are going to write, negative or positive? This should be negative. I think this sign is very important. Z square by n square plus SC by lambda dash. I think better to write. So what to do here? HC or this shall we write energy of photon? No need of lambda. E lambda dash. Everything will come in electron volt. We can compare. What should be the value of Z? Helium 2. What should be the value of N? 5. Substitute, you'll get E lambda dash. .376 electron volt. No. After this, again you have to check is there any photons which will lie in this region because it undergo de-excitation. For that, there's no other way. If you have the energy level diagram of helium plus, then you can manage here. So which number of photons, how many photons that will lie in this region of 2 electron volt to 4 electron volt. So 3.376, I think we can take it, no? This is emitted during. Then after, again you have to check it. Any photons will lie in this one. So for that, what you should do? You should draw an energy level diagram. lambda 54, then lambda 41, lambda 42, lambda 31, next after this it will be lambda 32, lambda 21. 10 photons are there, whose energy will lie. I think rather than don't calculate lambda. Just I wanted so just get the energy levels of all this. So I again directly use this formula. How to get the energy? That one, En is equal to minus 13.6 electron volt z square by n square. And the exam, if you remember these values, you'll be in better position. The difference of energy where that will lie between 2 electron volt and 4 electron volt. Ek how much? 3.1, huh? 3.1 minus. Okay, this one 3.11 minus how much is 1.9. That is correct. I wrote that one only. 1.2 electron volt. Okay, somebody. Yeah, I didn't check it. Yeah. You have to work out further. I'm just leaving it here.